purpose of this demonstration is to show some of the properties of light that artists have taken advantage of for thousands of years. We are going to try and understand how from simple white light, sunlight, we generate all of the colors that are portrayed in artists' materials. Those materials actually cause a transformation of the white light into the colors that the artists intend to portray. So, our questions are this: how does that transition occur? How do we perceive that transition? And what happens between the artwork and our perception? Let's demonstrate then the importance of white light in observing the materials that artists generate. So here we have white light showing on a white paper board. And if we want to change that white light to some color that we observe in an artwork, we can take a filter and simply impose it between the source of the light and the object. And what do we see? Using a blue filter, we see blue light. This is a little bit counterintuitive in everyday life in the sense that when we say filter, we usually mean we're removing something. In this particular case, we are removing everything except the blue light from the blue filter. Let's now change the filter and use a green filter. And again, we observe the color of the filter that's being projected, white light on one side, green light on the opposite side of the filter. Finally, if we use a red filter, we expect now to see red light, and indeed, that's what we do. Just to show some of the properties of light, however, let's now change the source of the light and use a laser. So, just as we did with the white light, we see the laser on the white background. That's fine. If we take a red filter, shine the laser through the red filter, it's the red light that's transmitted, just as we expect after seeing what had happened with the white light. Let's now take the green filter and do the same thing. And we see that there is absolutely no light projected through the green filter. Again, we might anticipate that would be the case since the filter projects only the color of the filter. Let's now take the blue filter and do the same thing, and we see exactly the same result, namely the red light from the laser is not transmitted through the blue filter. Why? Because when we say blue filter, only blue light will be projected through it. Let's now change the color of the laser from red to green and do exactly the same thing. Take our red filter, we expect to see red light projected through it. We show green light through it, and because of the strength of this particular laser, we see that there is a small amount of green light actually transmitted through the filter to the white screen, but most of the green light is filtered out. If we take the blue filter and do the same thing, we see, there is more of the green light projected through it. Why might that be the case? Well, in order to understand that, we need to see what the composition of light actually is. Before we do that, let's do one other thing. How does this green light get from the source laser to the screen? Why don't we see anything in between? We can visualize that if we take a spray bottle, just a little bit of water, and now you can see that some of the light is scattered from the small droplets, and we now know the mechanism by which the light gets from a source to an object. If we do the same thing with white light, just as most of you have probably seen in a movie theater, looking back at the source of the film, of the light, you can see actually the beam of light, but looking at the screen, you see nothing. Same kind of principle. Now, if we then take a source of white light and now decompose it into its components, what we see is a rainbow of colors, starting with blue, green, yellow, orange, and red. All of the colors of the filters that we actually used before. That's why when we put a blue filter in front of the white light, we see only the blue light. When we put a red filter in front of the white light, we see only or primarily red light. And finally, when we put a green filter in front, green filters, remember, pass green light, we see green light. Now, supposing then we take another light source. This particular light source is a series of helium atoms that we are passing through a very high electromagnetic field, and they are giving off what appears to be close to white light. On the other hand, if we disperse that white light into its components, we again see blue, green, yellow, and red. And as we did before, if we take a red filter, place it in front, we see now that only the red and yellow lines are transmitted. If we take the green filter, again, we see that primarily the green and blue lines are transmitted. And finally, the blue filter, the blue is more intense now, and the green lines are transmitted. Consequently, we conclude that light, white light, is a mixture of all of the individual components from blue through red. This demonstration has shown the importance of color in artists' materials. But beyond that, the question we want to raise now is, how can we explain generation of color in the materials themselves, in the medium through which those colors are projected, and in the observer who is seeing those colors? Does the observer actually observe the colors that the artist intended?